Hi, my
Recording
name
in
is In
progress.
Yoshimoto. I'm going to walk you through a Java class I've worked on called emission comparison. At first, it might look like a basic program that reads some data and prints a result, but it actually ties together programming fundamentals, real-world environmental data, and personal reflection. I'll be showing you what this class does, why it matters, how it works internally, and how it could be extended into a full sustainability tool in the future. Let's start with some context. We know that climate change is one of the most urgent issues in the world today. Governments track emissions by country and industry, but what about us as individuals? We all emit carbon dioxide through transportation, electricity, food choices, and more, but most of us don't know how much or whether we are above or below average. That's the motivating idea behind this project. Can we use a simple Java program to compare our carbon footprint to a national or group average? And more importantly, can this comparison help us change our behavior? So this class was built to serve both educational and environmental purpose. The emission comparison class is designed with two main responsibilities. First, it reads numeric idea from a file and calculates the average. Second, it compares the average with a value stored in a carbon footprint object. Think of it like this. The dataset is a group of people's emissions. The user has their own personal emission total. The program asks, are you above average or below? The class contains two key public methods: calculate average from file and compare to dataset. Let's now take a closer look at how these work. Method 1. Calculate average from file. This method is responsible for reading a file line by line, exa exa extracting numerical values, and calculating the average. Let me show you the basic structure of this method. We start by initializing a sum and count. Then we create a file object and use scanner to read each line. We trim white space, keep empty lines, and then parse each line as a double. Each value is added to the running total and we increment the count. At the end, we return the average by driving the sum by the count, but only if the count is greater than 0. If not, we return 0 or an error. This method is a practical example of how to read real-world data files, clean the input, and process them safely. It's something that professional programmers do all the time, not just for climate data, but in business, healthcare, and more. Method 2. Compare to data. Once we have the dataset average, we can compare it with the user's carbon footprint. That's what this method does. That's what this method does. If the average couldn't be calculated due to an error, for example, file not found, we stop and show a message. Otherwise, we do a simple comparison. The message is friendly and readable. Instant uh, it gives user instant feedback. And the beauty is that is concept personal behavior to measurable numbers. Exception handling. Real world data isn't always clean. That's why these cases include exception handling. For example, if the file doesn't exist, like this, and if a line contains a value that's not a valid number, handling errors like that prevents the program from crashing and shows users helpful messages. As students, we often forget how important error handling is until we face real input problems. From a design perspective, this class follows clean, object-oriented principles. It assumes a carbon footprint object has been created separately, maybe using getters and setters, or based on user input. This separation of concerns, one class stores the user data, and one class compares it, makes the code more modular, easier to maintain and easier to test. Also, the use static methods here makes the comparison logic reusable without needing to ins- instantiate the class. The emission comparison class might look simple, but it combines technical accuracy with social purpose. It teaches us not only how to code, but why to code and how to use programming to understand the world around us. Thank you very much for listening.
My name is Yeho Yin, and I'm going to present about my module. This is public class carbon footprint, and this section are instant variables to store emission values. Double transport emission is to store emission from transport. Electricity emission is to store emission from electricity, and total emission is total emission from transport and electricity. And this public carbon footprint is a default constructor which allows creation of an empty object with no value set. And public carbon footprint is a parameterized constructor. This line assigns transport emission. This line assigns electricity emission, and this total emission calculates total emission from transport and electricity. And then for this section, we have getter and setter for transport emission, electricity emission, and total emission. All these return their own respective variables. And then we have an override method to return transport emission for monthly and transport emission for yearly and electricity emission for yearly and total emission from annually transport emission and electricity emission. And this class, public static carbon footprint, is to calculate the footprint emitted. Double transport emission, double electricity emission, and double total emission have to be initialized to store calculated values. And this is the transport choices that the user can choose. This line reads the transport choices that the user chose, and this output will be presented. And then the user have to input the distance traveled, and the system will read the input again. And then if the user choose option 1, you will calculate the transport emission for the sedan vehicle. Case 2 will calculate transport emission for the SUV vehicle, and case 3 will calculate the transport emission for MPV vehicle. And let's say the option is not from 1 or 2 or 3, the system will display invalid transport type, which is the default display. And then this section is to calculate the yearly electricity carbon emission. So we have the user to input their average monthly electricity usage in kilowatts. And then to calculate yearly carbon emission by electricity, we have the kilowatts multiplied by 12 and the factor of it. And then this section, we create and return carbon footprint object and display the object and return the object for comparison. For our driver class, we have the main method, and this displays multiple challenges that the user will need to do. This section, we randomly choose one of the challenge here and display it for the user. And then we have a welcome message to welcome our user to use our program. And this section is our main menu loop, and this is our main menu displayed. And then for this section, it ensures that the user inputs an integer instead of string. And if the user chooses option 1, carbon footprint calculator, the class will be run and calculate the carbon footprint. Case 2 will run the 7-day scenario simulation. And option 3 will let the user view their past emission logs. And in case the user wants to exit, the user have to input 0 to exit the program. Okay, let's say the user wants to calculate their footprint calculator. They will have to choose their mode of transportation and enter their distance traveled per week, which is, I would say, 250. And the electricity usage, okay. And here it shows the transport emission per month, transport emission per year, and electricity emission per year. And the total is from the total emission by transport per year and total electricity emission per year. And then the system will compare the user's total emission and compare it to the data set and see if it's above or below average. And let's say we'll run the second scenario, second simulation. We have to enter our username. And then we just have to choose our transport and choose our meal and energy usage. And just repeat these choices for 7 times. Okay, and it will show the estimated carbon emission by the user, which is 10.2 kg. And then you calculate the weekly carbon footprint emission, which is 45.90 kg. And then the system will suggest some improvement for the user so that the user will try to emit lesser carbon emission. And then the result will be saved and be exported to the emission logs text file. To view the past emission logs, and here is it. This is my carbon emission for the past week. And then in order to exit the program, 0, and the program will stop running.
My name's Vincent Lim Jichen, and I'm responsible for the Model 2, which is the scenario simulator class. All right. The scenario simulator class is the core of our carbon footprint simulator program. So this class simulates a user's daily activity, calculates their carbon emission, and provides suggestion based on their overall impact. I'll guide you step by step, explaining each part of the code from the input collection to the emission calculation and the final suggestion. Okay, first, this is the whole class of the scenario simulator, and this is the run class. The run class method is the main driver of the simulation. It guides the users through the 7-day simulation process. And this is the calculate total part. And this is for each day method which is responsible for collecting users' input for each activity, like transportation, meal, and energy usage for one day, then calculating the total emission based on their choices. This is the public in get choice, which is the method is a helper function that takes the user's input for their daily choices, and then such as the transportation, meal, and energy options, and calculate. The calculate is here, the calculation total. The calculate total method calculates the total carbon footprint for the entire week by adding up the emission of each day. And this is the method which is provides the user with suggestion based on their carbon emission grade. This is the class of the user emission log, which takes in the record of the user. And I'll go line by line by now. These are arrays for better storing, and they need to be set as private because it only works for the scenario simulator. So transport options are a petrol car, public transport, and walk bike. And these are the meal options. These are energy options. Okay, for the run method, it will prompt the user to enter their username here and saves it into the scanner in line 31. And this is a loop for each day. It's a counter control loop, and the number of times of the loop will execute is known. So that's why it's a counter control loop. This line displays what day it is on during the simulation. This line calls the simulate day class and runs it. This line stores the answer in the array by which day. Like for say it's on day 1, it will store on day 1 in the array. This line calls the calculate total method, which is here, and calculates the total and return the value in double. And this line gets the total from the calculate total class of the carbon emission of a week for a week. After getting the total, it will use the provide suggestion class to give the output depending on the total, and then saves the log using the user emission log at weekly log with the parameterized things, which is the username and the total. This class is to simulate and record one day's worth of users' choices, which is parameterized to the transport and meal usage. The user should choose only one option from the transportation array, which is the string option, and these are for the tree. This part is for counting the total emission and getting the choices from the options. So this is the get choice class, which has two parameters which are string type, the string type, and options, which is a string array initialize. This is the for loop which runs for each option in the array. And this line is the percentage %d is a modular, which is for integer to display the option index, and the percentage %s is for strings option modular. This part prompts the users to enter a valid choice and do the while loop. The while loop has a special thing, which is it does the code before checking. And this line asks for the users to enter a number between 0 to the last index of the option array, which is like there's three choices. It should print like 0, 1, and 2. If the user doesn't input a valid integer, it will use this line to skip it over, and the loop can continue. This method is to return the total as a double value, and this line is to initialize the variable total to 0 to declare it as for say. And this is the for loop, which loops through each element in the array, and the array is weak choices of the day choices object. This calculate total class returns a rounding of two decimal integer. For say the total emission is below 30, which is under this class, else it will print this. Excellent, yeah, just print this statement. If it's over 30 but less than 50, it will print this. And if over 50, it will print all of these. And then this is the user emission log, which has limits to 50% logs, and the username and emission is 50 also. When we want to add a weekly log, we will use this class, which is parameterized to a string username and the double total emission. And this is a counter control loop for it. If it is more than 50, then it prints this statement telling the user there is no storage for more logs in the array. This method is to display the logs of the users, and this is the if loop. If nothing, oh sorry, is if no input log. Yeah. If there is no input before the user, it will print this statement. If there is a input before the user, it will print this statement, which has the loop inside of it. This loop will loop for exactly as many times as there are logs recorded in the array. And this section is the class will export the file to a txt file, which is printing the array of the display all logs class. This line is to write a header line to the file to indicate the start of the logs. This line is for the for loop, and it loops through all the logs stored in the array, such as the username and emission. And then it writes the log entry to the file in a formatted way. This is the module I said just now. And then it will print this message confirming that the logs has been successfully exported to the file. And these are the getters, setters, and constructors of the day choices class. This is used to store and manage one day's worth of user input and emission data. And here we are declaring the class attributes which is only for this class and only accessible for this class with because of this private. This is the default constructor, and this is the parameterized constructor. Parameterized constructor is used to create an object with values, and and creates a new day choice and initiates its value when created. Getters are to read values from the object, and setters are to change and update values in the object, which is not used now because the program is using a parameterized constructor. And that's all.